Advanced Math Lesson 94, graphs of secant and cosecant, and then graphs of tangent and cotangent. So, got my cool little dry erase coordinate plane here today. So I need to adjust my focus. There we go. All right, and we'll start with the graphs of secant and cosecant. If we remember, secant is equal to 1 over the cosine, and cosecant is equal to 1 over the sine. So, in order to show this, what I'm first going to do is I'm going to graph sine and cosine. So, if you remember, sine passes through 0 positively. We'll just make every 4 dots a length of 90 degrees, because that makes sense. And I'm going to go ahead and just neatly finish my graph of sine. Okay, so here I've got the graph of sine. Now the graph of cosecant, or 1 over the sine, is very interesting because it will almost meet sine at these 4 crests or peaks. And what it does is it goes in the opposite direction. It actually forms parabolas going in the opposite directions. And the interesting thing is that each of these parabolas going in opposite directions runs up against asymptotes. So we have vertical asymptotes that run across the graph of cosecant. And we can see here the graph of cosecant in blue, and it just makes these parabolas that run up against those little boundaries that we set for them. So this here is the graph of cosecant. The graph of secant would be the exact same thing, but with the cosine. So if you remember, the graph of cosecant, or 1 over the sine, at 90 degrees is equal to 1, and then has no value at 0 or 180 or at negative 180, etc. I should probably put those values in there. So we're at 0 degrees, 180 degrees, negative 180 degrees, and pretty much every 180 degrees you're going to hit a vertical asymptote for the graph of cosecant, tongue-tied, excuse me. Now let's say we wanted to do a vertical shift, or sorry, not vertical, or horizontal shift. Let's say we wanted to do the graph of cosecant of theta. We'll do minus 90 since that's the most drastic one. All right, so if we did minus 90, we'd actually be moving to the right 90 degrees, which means we would just shift everything over 90 degrees. So then the asymptotes would get shifted 90 degrees. Let me erase some of this here. Maybe I'll erase all this, and I'll just show you cosecant of theta minus 90. So if you remember, we said that at 90, that's usually where the peak is, but if it gets shifted to the right 90 degrees, that means my asymptote is now going to be at 90 degrees, and then if I go another 180 degrees over, there will be another one, and then 180 degrees to the left, another one, and then we remember that to the right of the first one is where the first curve is going to be, and then to the left of the first one, see here, 1, 2, 3, 4, we've got the first downward curve, and then it continues in that fashion. Throughout the graph. So this would be cosecant shifted 90 degrees. Now let's say we put a coefficient in front of it. So let's say we did the graph of 2 cosecant equals 90. Well, then we have to change the point of the crest and the height. So the height would then be at 2, the trough would then be at negative 2. So the crest is at 2, trough negative 2. So that's what a coefficient does. Really quick, we'll look at the graph of secant. All right, and then I'll also do that. I'll explain that in terms of drawing the graph of cosine first. So we'll do the graph of cosine in green. If you remember, cosine at 0 is equal to 1, and then it goes down and then back up. So then we have a graph that looks like this. Okay. Now, just like sine, just like cosecant, secant is going to be the opposite of the troughs. And it's going to be bound by vertical asymptotes. However, these asymptotes will be 180 degrees apart, starting at positive 90, negative 90. All right, so that's the difference between the secant and the cosecant. So here we've got positive 90 degrees, here we've got negative 90 degrees, and then the next one will be at positive 270, and then at negative 270. Those are where the asymptotes would be. And then, again, the opposite of the crests, we put parabolas. All right, and that's the graph of cosecant. Let's see here. Oh no, we're 6 minutes in and I've only done the first two. Now we have to go over the graphs of tangent and cotangent. All right, let's see if I can speed this up. I'm going to pause and then set up the next. Okay, here we go. So I've just drawn the graph of tangent. I forgot to put in my degree mark. Actually, I could have left the same asymptotes in that I had for secant. Interesting side note, trivia, secant and tangent have the same asymptotes, just in case you were wondering. Now we know. So the graph of tangent is kind of like the graph of x cubed, I believe. It's very similar to the graph of x cubed. I'm not going to say it's exactly the same because there's some weird stuff we do in calculus where you look at x cubed and you see it's got like a little mini wave. That's a side note. We don't have to worry about that. Let's focus on tangent. So tangent has a very drastic climb and rise. This actually isn't even a very good depiction of it. I'll have you guys graph this out in a math lab someday, but it'll stay very, very close to almost zero until we get really, really close to 90 degrees, and then it skyrockets up into infinity very, very quickly. So you notice I tried to show that in all of these curves, that they stay really, really close to zero until they get close to their asymptote, then they just shoot up like that. So this is the graph of tangent. The negative graph of tangent would then just be this, but flipped reversed. So it would then go in this direction. So we'll say the negative tangent of theta would look like this. Okay. What else do we have? Coincidentally enough, this negative tangent is also equal to the graph of cotangent. All right, so those are actually the exact same graph. And then the last thing we're going to talk about, what if we expand the graph with a coefficient? Let's say we took our graph of tangent of x and then we made it 3 times the tangent of x. What in the world would that do to the graph? Well, it makes a huge difference. I'm actually being facetious. It's not that much of a difference. All it does to the graph is it just raises it up a little bit. So it kind of go up to 3 pretty quick, and then it just makes it rise faster. Right? So you kind of exaggerate the bend of the graph, or the curve of the graph, right? So you cut a little bit of that bend off. And I'm kind of trying to make sure that it gets close to that 3 mark. But that's all that would do. It just kind of makes it a little more narrow, not as wide. Hey, that's it for this lesson. I got so nervous at secant and cosecant that I was taking too much time. I guess I forgot that cotangent is very simple. The graph of cotangent looks just like the graph of negative tangent. And then if you were wondering, the graph of negative cotangent looks just like the graph of tangent. So that's all there is for this lesson. If you have any questions, let me know on the school website, and I will see you in class.